The CPU, Central Processing Unit, the brain of the computer. A tiny square of silicon packed with billions of microscopic transistors. It executes every single instruction and handles all logical calculations for the entire system. CPU socket, the interface. Found directly on the motherboard, this specialized grid of tiny, fragile connectors is precisely engineered to accept and lock down a specific generation of CPU, creating thousands of points of electrical contact. Motherboard, the main board, the nervous system of the computer. A massive printed circuit board that physically and electronically connects every single component, from the CPU and RAM to storage and expansion cards. RAM stick, random access memory, also known as DIMM modules. This is the computer's short-term, super-fast working memory, holding data actively used by open applications and the operating system for instant retrieval. DIMM slot, the memory interface. Long, narrow slots located directly on the motherboard, equipped with small locking tabs on the ends to physically secure and electrically connect the RAM sticks to the system bus. GPU, Graphics Processing Unit. While the massive expansion card is technically the discrete video card, the actual GPU is the dedicated processor inside that visualizes all 3D graphics, heavy video rendering, and complex visual data. PCIe Slot, Peripheral Component Interconnect Express, the high-speed expansion bus on the motherboard. These distinct slots connect powerful add-on hardware like GPUs, sound cards, and rapid storage drives directly to the CPU for maximum bandwidth. NVMe SSD, Non-Volatile Memory Express Solid-State Drive. Represented here by the compact M.2 form factor, this ultra-fast storage drive uses flash memory chips, completely bypassing traditional moving parts to deliver incredible data read and write speeds. M.2 Slot, the compact storage interface. A small, horizontal connector found directly on modern motherboards. It is engineered specifically to accept ultra-fast NVMe SSDs or wireless cards, often utilizing a single tiny screw to secure the drive in place. SATA SSD, Serial ATA Solid-State Drive. Housed in a standard 2.5-inch shell, this storage drive uses flash memory just like NVMe drives, but connects via the older, slower SATA interface, making it perfect for mass data storage and backups. HDD, Hard Disk Drive, Traditional Mechanical Storage. Inside this heavy enclosure, physical magnetic platters spin at thousands of RPMs, while a mechanical arm reads data, offering massive storage capacity at a low cost, but with far slower speeds than SSDs. SATA Cable, the data link. A narrow, distinct 7-pin data ribbon. This cable is the mechanical connection used to link HDDs and standard SSDs directly to the motherboard's SATA data ports for data transfer. SATA Port, the interface socket. A specialized L-shaped 7-pin socket, often found in rows along the edge of the motherboard. These ports act as the receiving end, physically accepting the SATA data cable to connect storage drives to the system chipset. PSU, Power Supply Unit, the computer's power plant. This heavy metal box converts dangerous high-voltage AC power from your wall outlet into clean, stable low-voltage DC power needed by every single component inside the PC. Main 24-pin ATX cable, the motherboard power link. The single largest, most complex power delivery cable in the entire PC build. Connected directly from the PSU, it plugs into the edge of the motherboard, providing crucial power to the chipset, memory slots, and PCIe bus. CPU air cooler, the heat dissipator, a massive tower of thin aluminum fins stacked onto copper heat pipes. It draws extreme, concentrated heat directly away from the processor and uses an attached fan to violently blow it away. Thermal paste, the heat bridge. A specialized, highly conductive gray compound housed in a plastic syringe. Microscopic imperfections exist on even the smoothest metals. A tiny drop of this paste fills those invisible gaps between the CPU and the cooler, ensuring perfect thermal transfer. AIO Liquid Cooler, all-in-one cooling. A closed-loop water cooling system. A localized pump sits directly on the CPU, quietly pushing specialized liquid through thick rubber tubes to a massive radiator, where multiple fans blast the heat completely out of the case. Case fan, the airflow engine, typically 120 millimeters across, strategically mounted to the front, top, and rear of the computer chassis. These rapidly spin to pull fresh, cold air into the system and aggressively exhaust the hot air out the back. VRM Heatsink, the voltage cooler. Chunky, heavily grooved blocks of solid metal bolted directly to the motherboard around the CPU socket. They absorb and dissipate the extreme heat generated by the tiny voltage regulators that feed the power to the main processor. M.2 Heatsink, the drive armor. A flat, sleek strip of thermally conductive aluminum shroud. Because ultra-fast NVMe drives can easily overheat and throttle their performance, this metal shield screws directly over the drive to absorb the heat and keep data speeds maxed out. CMOS Battery, the memory keeper. A simple, shiny CR2032 coin cell battery plugged directly into the motherboard. Even when the computer is completely unplugged from the wall, this tiny battery keeps the motherboard's internal clock ticking and saves your fundamental BIOS settings. 8-pin CPU cable, the processor's lifeblood, also known as the U.P.S. power cable. Running directly from the power supply to the top left corner of the motherboard, it delivers a dedicated, massive stream of 12-volt power exclusively to the hungry central processor. PCIe Power Cable, the graphics fuel. Usually featuring a split 6+2-pin configuration, modern graphics cards require vastly more power than the motherboard alone can provide. These heavy-duty cables plug directly into the side of the GPU to feed it pure, unrestricted wattage. Front panel connectors, the tiny nightmare. A cluster of microscopic individual pin cables coming from the computer case. These must be plugged into exact, specific needles on the bottom of the motherboard, allowing your physical case power button, reset switch, and indicator lights to actually function. USB 3.0 internal header, the front panel data pipeline. A massively thick, rigid cable with a large blue tip. Plugging into a tightly secured socket on the motherboard, it routes high-speed data connections directly to the blue USB ports on the front of your computer case. HD audio cable, the sound router. A thin, multicolored or black ribbon cable with a distinct blank pin in its connector, usually routed all the way to the bottom left corner of the motherboard. It physically connects the motherboard's onboard sound card to the headphone jacks on the front of your case. PWM Fan Header, the smart socket. A tiny 4-pin plastic socket sticking straight up from the motherboard. Pulse width modulation allows the motherboard to talk directly to the case fans, automatically ramping their speeds up when the system gets hot and slowing them down to stay silent when idle. ARGB Cable, the light controller. Addressable RGB, a delicate 3-pin cable with a noticeable gap in the middle. Running on precisely 5 volts of power, it connects your glowing fans and light strips to the motherboard, allowing software to dictate complex, shifting rainbow patterns. Fan Hub, the central distribution board. A small, standalone printed circuit board hidden behind the back panel. When you have more fans than motherboard headers, this acts as a master splitter, taking a single signal from the motherboard and distributing perfectly synced power and lighting instructions to up to 10 fans at once. RJ45 Ethernet cable, the hardline connection. A thick wire containing 8 twisted pairs of copper. Capped with a clear plastic clip, it physically tethers your computer directly to the local network for the most stable, uninterrupted internet speeds possible. Ethernet port, the network interface. A square metal-shielded socket found on the back of the motherboard or router. It perfectly receives the RJ45 cable, utilizing microscopic gold pins to translate raw electrical pulses into usable digital network data. Wi-Fi antenna, The wireless receiver. A sleek, adjustable plastic fin or dual-stick configuration attached to the back of the PC. Instead of copper wires, it captures invisible high-frequency radio waves traveling through the air and funnels them directly into your computer's wireless card. Network switch, the traffic director. A standalone metal box lined with a row of Ethernet ports. Used in offices and server rooms, this device intelligently connects multiple computers together. SFP Transceiver, the laser bridge. A small, hot-swappable metal cartridge plugged directly into enterprise switches. Small form factor pluggable. It acts as the ultimate translator, converting the switch's electrical signals into the blinding light flashes required for fiber optic cables. Blade server, the cloud's workhorse. An ultra-dense computer designed to be shoved into a massive rack. Lacking a standard case or power supply, thousands of these identical flat metal modules are stacked together in massive data centers to power the modern internet. Rack, the data skeleton. A towering, heavy-duty steel frame measured in standardized U units. Bolted to the floor in freezing cold rooms, it safely houses, organizes, and powers millions of dollars worth of densely packed switches, routers, and blade servers. USB Type-A, the universal standard. The rectangular plug that revolutionized computing. Found on keyboards, mice, and flash drives, it is famous for strictly only plugging in one way, usually requiring you to flip it 3 times before it finally goes in. USB Type-C, the new generation. A much smaller, perfectly symmetrical oval connector. Not only is it finally reversible so you can never plug it in wrong, it carries vastly more power, video signals, and data at blazing fast speeds compared to the older standards. HDMI Cable, the entertainment link. High-definition multimedia interface. Featuring a distinct, slightly tapered metal plug, this single thick cable simultaneously transmits uncompressed high-resolution digital video and crystal-clear audio from your PC directly to your monitor or TV. DisplayPort Cable, the gamer's choice. Often confused with HDMI, this plug features a flat side and a sharply angled corner, often with physical locking clips. It boasts massive bandwidth, allowing high-end graphics cards to push insane refresh rates to gaming monitors without breaking a sweat. C13 Power Cable, the heavy lifter. Universally known as the kettle cord. A thick, heavy-duty insulated wire with a chunky 3-pronged trapezoid connector. This is the main physical lifeline that carries dangerous wall voltage directly into your computer's power supply and your external monitors. Bluetooth dongle, the invisible bridge. A microscopic USB plug that barely protrudes from the computer case. Containing a tiny radio transmitter, it allows a desktop PC to instantly pair with wireless headphones, controllers, and smartphones over short distances. Patch panel, the network switchboard. A wide, flat metal board mounted into a server rack covered in rows of numbered Ethernet ports. Instead of cables turning into a massive, tangled rat's nest, this organizes hundreds of incoming wall cables into neat, labeled rows, keeping the data center perfectly organized. Mechanical keyboard, the tactile input. Unlike mushy laptop keys, every single keycap on this heavy board sits on top of its own physical spring-loaded mechanical switch, delivering precise feedback and that satisfying click. Gaming mouse, the precision pointer. A highly ergonomic, lightweight shell packed with extra programmable side buttons. On the bottom, a microscopic optical sensor scans the desk surface thousands of times per second to translate your physical hand movements into flawless digital aim. Computer monitor, the digital canvas. A massive, ultra-thin flat panel display. Inside the thin plastic bezel, millions of microscopic pixels made of liquid crystals or organic LEDs rapidly change color to visualize the raw data being pumped out by your graphics card. Webcam, the digital eye. a compact digital camera that clips directly onto the top of your monitor. Featuring a tiny glass lens and built-in autofocus, it captures your face in high-definition video and compresses the footage for instant live streaming and video calls. USB microphone, the vocal capturer, a heavy standalone studio microphone designed for your desk. Inside the metal grill is a highly sensitive condenser capsule, which instantly converts the physical sound waves of your voice into a digital signal using a built-in audio interface. Audio interface, the sound translator, a heavy metal box covered in volume knobs and complex inputs. For professional creators, this external sound card takes raw analog audio from high-end studio microphones and translates it perfectly into a digital format your computer can record. XLR Cable, the Pro Audio Lifeline, a thick, heavy-duty circular cable. Used exclusively in professional audio, its massive metal connector houses 3 distinct pins, delivering a perfectly balanced, noise-free analog audio signal from a microphone to the interface. Studio headphones, the audio monitors, large over-ear cans designed for absolute audio accuracy. Unlike consumer headphones that artificially boost the bass, these feature flat response drivers, allowing editors and producers to hear the completely raw, unaltered truth of their audio tracks. USB flash drive, the pocket storage, a tiny, durable plastic or metal stick. Despite being smaller than a lighter, it contains a powerful flash memory chip, allowing you to instantly carry gigabytes of physical data, photos, and files in your pocket without an internet connection. SD card, the camera memory. Secure digital, a microscopic plastic wafer thinner than a credit card. Lined with tiny gold contact pens, this is the universal storage standard for digital cameras, drones, and portable devices, saving high-resolution media directly to solid-state flash. External hard drive, the massive backup, a thick plastic brick containing a full-sized mechanical spinning disk. Connecting via a single USB cable, it sits safely on your desk, offering a cheap, massive digital vault to permanently back up your entire computer system. U.P.S. Uninterruptible power supply, a massive, incredibly heavy battery backup for your desk. When lightning strikes and the power grid completely fails, this device instantly takes over, feeding emergency battery power to your PC so you have 5 minutes to safely save your work and shut down. Capture card, the stream engine, a sleek external box or internal PCIe card. Placed directly between a gaming console and your monitor, it forcefully intercepts the raw video signal, copying it in real time so your PC can broadcast your gameplay to the entire world. KVM Switch, the desk master, keyboard, video, and mouse. If you have a work laptop and a gaming PC on the same desk, this heavy metal box lets you instantly control both computers using just one single monitor, one keyboard, and one mouse at the push of a button. USB hub, the port multiplier, a slim plastic strip featuring a row of extra USB slots. Because modern laptops and motherboards never have enough ports, this device plugs into a single socket and instantly splits the data lane, giving you the physical space to plug in all your extra gear. Resistor, the current controller, one of the most fundamental electronic components. A tiny, often color-coded cylinder that provides a specific amount of electrical resistance. It physically restricts and controls the flow of current, converting excess energy into trace heat to prevent delicate components from receiving too much power. Capacitor, the energy reservoir, a critical component with 2 distinct jobs, storing and filtering. It acts like a tiny battery, temporarily holding electrical charge between 2 conductive plates and rapidly releasing it to smooth out noisy voltage spikes or deliver a quick burst of power when needed. Inductor, the magnetic shield, a tightly wound coil of copper wire. While capacitors store energy in an electric field, an inductor stores energy in a magnetic field. Because it aggressively resists changes in current, it acts as a critical low-pass filter, blocking high-frequency noise from passing through. Transistor, the universal switch, the single most important invention in modern computing. This tiny three-pronged component has zero moving parts, but acts as either an extremely fast on-off switch to process digital logic or as a powerful amplifier to boost weak electrical signals. Printed circuit board, the digital foundation. PCB, the heavy-duty green or black substrate. More than just a piece of plastic, it is an intricately layered network of microscopic copper traces physically connecting and routing power and data between hundreds of individual microcomponents. Solder, the digital glue, a low melting point alloy of tin and lead or other metals. With the specialized iron, the technician melts this silver wire, allowing it to flow around component pins to create a permanent, electrically conductive, and incredibly durable physical bond to the PCB pads. Raw silicon wafer, the microscopic roadmap. A massive, impossibly thin disk of hyper-pure single-crystal silicon. Using advanced photolithography, engineering firms build millions of microscopic transistors and logic gates directly onto this flawless surface, physically creating the individual CPU and memory chips that power the internet. Bare die, the raw, physical CPU or GPU chip immediately after being cut from the silicon wafer, but before being sealed into its final ceramic or metal protective package. It is a terrifyingly delicate array of microscopic transistors, logic blocks, and memory structures ready for final assembly. IC, integrated circuit, also known as a microchip, the compact functional microcircuit. The bare die is permanently sealed inside this protective plastic or ceramic package, creating a single, complete microcomponent containing an entire computer system, an amplifier, or a complex memory bank ready for integration into the PCB. BGA Chip, ball grid array. A high-density chip package typically used for major processors and memory. Instead of long pins or tabs, this chip's bottom surface is covered in hundreds of tiny solder balls, which are carefully melted to create hundreds of connections and permanently mount the component to the PCB surface. The PC chassis, the armor, a heavy steel, aluminum, and tempered glass enclosure. Far more than just a decorative box, it provides the rigid physical skeleton to mount your components, actively directs airflow, and shields delicate silicon from dust and impacts. Motherboard standoff, the crucial spacer. A tiny hexagonal brass pillar. Screwed directly into the back wall of the case, it physically elevates the motherboard a few millimeters off to bare metal, completely preventing catastrophic electrical shorts that would instantly kill the system. Zip tie, the cable tamer. A simple plastic fastener with a one-way ratcheting gear. While seemingly basic, it is used heavily by professional builders to aggressively bundle and hide the massive web of internal wires, ensuring clean, unobstructed airflow and a flawless aesthetic. Anti-static wrist strap, the component lifesaver. A fabric band containing conductive threads attached to a coiled grounding wire. Worn tightly around the wrist, it safely and instantly discharges invisible static electricity from your body before it can jump and completely destroy a delicate $1,000 processor. I/O shield, the dust barrier. A thin, stamped rectangular piece of aluminum. Before the motherboard is installed, this sharp metal plate snaps into the back of the case, perfectly framing the external ports while blocking heavy dust and reducing electromagnetic interference. Motherboard speaker, the error alarm. A tiny cylindrical piezo buzzer attached to a very short black and red wire. Before your monitors even turn on, it uses a highly specific sequence of loud beeps to instantly tell you exactly which component is failing during the power-on self-test. Digital multimeter, the electrical detective. A handheld diagnostic device featuring a digital screen and two sharp metal probes. When a computer completely dies, it allows technicians to physically measure raw voltage, current, and continuity, perfectly pinpointing dead circuits on a broken motherboard. Power supply tester, the voltage checker. A small aluminum diagnostic box with an LCD screen. Instead of risking a brand new motherboard, you plug the massive 24-pin power cable directly into this device to instantly verify if the power supply is safely delivering the correct, stable voltages. Magnetic screwdriver, the builder's wand. specifically a long-necked Phillips size 2. While seemingly ordinary, the highly magnetized tip is an absolute necessity, allowing you to easily guide tiny screws deep into the case without dropping them into the dark abyss of the power supply shroud. Isopropyl alcohol, the safe solvent. High-purity 99% alcohol in the plastic squeeze bottle. Because tap water instantly destroys electronics, technicians use this rapidly evaporating liquid on a microfiber cloth to safely scrub away old thermal paste and stubborn dirt directly from bare silicon chips.